Hello, everyone. My name is Shimi Bandiel. Welcome to the Automating DevOps for the Automotive Industry webinar. I hope you are all currently safe in this crazy situation we are at. So today I'm going to talk about best practices and how we've seen, our customers from the automotive industry implementing DevOps for the processes. So introducing myself, my name is, as I've said, Shimi Bandiel. I'm a solution architect in the DevOps acceleration team at JFrog. And today what we are going to discuss is modern DevOps practices with special focus on the automotive industry. We're going also to talk about DevSecOps, why it matters, and again, best practices and tools to implement it. We are going to focus a lot about distribution, how it can be used, the use cases that appear in most of the pipelines and delivery operations that are required in the automotive industry. I'm also going to talk a bit about last mile deployments and my thoughts on that. We say this is a very problematic area, which we are going to address later. And of course, during the session, we're going to talk about specific challenges that are common in the automotive industry. There will be also a lot of demos on the tools and capabilities sprinkled, during the entire session. So let's get started. So life runs on code. These days, modern days, everything is based on code. If it's like medical devices, if it's utilities, space shuttle, and of course, in our industry focus for this webinar, automotive industry, whether it's regular cars or autonomous driving cars, we're talking about huge amounts of code. We're talking about, hundreds of millions, mentioning here 120 million lines of code, but there are different vendors, it gets up, to 300K or even higher than that regarding lines of code. And, it's not specific to this industry. Everywhere the world is running on software, essentially. And by the way, if you're not familiar with JFrog's vision, our vision is called liquid software. We believe that software updates should be continuous, should flow like water. And we aim to provide you with the best, pipes, or you can say pipelines, to get to this state of liquid software. Okay, so we're focusing on DevOps in the automotive industry, but before that we need some way of measuring. Are we doing good? What should we focus on? We need some measurable metrics to know if we are doing like DevOps in a good way, where can we improve, etc. So DevOps, there's a definition here. Someone coined DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. In our use case, end users, most probably, comes to mind, it's the car, updates to the cars themselves. Keep in mind that there's a lot of internal software as well. So, there are, huge variety of types of software that, flows in large organizations that, belong to the automotive industry. So DevOps often feels like this. We are trying to put down fires. We have a lot of criticals, but we should aim to be there. Everything is automatic. Everything is not entirely autonomous, but, we don't need to deal with fires every other hour. And, we want our DevOps pipelines to be like this, to enjoy seeing everything operate smoothly. But how do we get there? Okay, so how do we measure DevOps? So the classic metrics for measuring DevOps are, lead time, deployment frequency, time to restore service, and change failure rate. Just, going over them quickly. Lead time, how much time it takes from a commit. A developer, produced software change, committed that to the Git repository. How much time does it take for that change to reach production? This is called lead time. The shorter it is, the better, the metric is. Deployment frequency, how frequent are our deployments? In some industries, maybe it's once a quarter. In other industries, it's like every minute, update your software. Time to restore service, something goes wrong in production. How long does it take for us to, restore service to operational state? And change failure rate, the rate of which software updates fail. I updated my device, my endpoint, and then, something is wrong. Specific to the automotive industry, if I'm looking, across our customers, what we identify is that the most important metrics, and I try to make them larger. Everything is important here, of course, all four, but I believe change failure rate, this is the most critical. We don't want, defective software reaching the endpoint. After that, it's lead time. We need to fix a critical issue. We have, I don't know, new security vulnerability. How fast do we get to applying that to production? Deployment frequency is important, but, I believe for this type of industries, like in the last place. And time to restore service, very important, but I think this depends more on the lead time, and change failure rate, I believe, is still more important than the time to restore service. Okay, what else is like specific or common across customers from, this vertical? Security and compliance, and I'll go, into this topic soon. Usually the software in a car is, with failures there can result in like life-threatening scenarios. So it's very, very important to try to have, no security vulnerabilities, follow compliance rules. It's very expensive. There's like the classical pie of how much cost, or how much does it cost to fix a bug, if it's in design or actually in production. So whenever we're talking about devices, it's usually very high cost to fix it in production. So we want to put a lot of regulations, a lot of compliance, a lot of quality gates during the process in order to make sure and get confidence that, no defective software reaching the endpoint. Second is the distribution. It's not only that the organization is usually highly distributed across multiple geographical locations. There are factories, there are test sites, and the developers are usually distributed, but also getting the actual software updates to the endpoints, it's also highly distributed due to the nature that, cars are everywhere, and also service centers are everywhere. So I will focus a lot on, the problem of distribution and how to apply best practices and tools to solve that. Other common characteristics are very large binaries. Usually the software updates, it's not like two lines of code of Python or two small jars of Java. It's a huge binary, usually embedded packages. We have test data, could be like high definition videos. We have machine learning models, which are usually very large. So large binaries are very common in this type of vertical. Languages and package management. Usually we see a lot of C, C++ oriented development. And I'll also talk about that. The endpoints are almost always embedded, embedded Linux, leveraging tools like OS3, Yocto for development, and combining the updates, and I'll focus on that later. Also, very common is processes for doing AI, especially for the autonomous driving cars. So customers dealing with that, usually there's a lot of AI, machine learning models involved in the process, and this usually requires also dealing with large data, and it puts, again, a lot of, restrictions about how can we do our software development, our DevOps in the right way. So before I continue, I just want to do a quick overview about the set of tools. This is the JFrog platform, and I want to just mention what's in the platform, do a quick overview, and then, focus on each of the challenges and each of the topics, and, show you some demos about how to apply the tool and how to leverage best practices and overcome common pitfalls that we commonly see. So JFrog platform, it's an end-to-end platform from Git, from your source control to the actual runtime. We usually say, it's a platform between Git to Kubernetes, but usually in our use cases in the vertical, the end target, especially with the cars, it's not Kubernetes. There may be Kubernetes internally for, internal development software and software processes, but this is not the focus here. I will not talk about Kubernetes here. What I do want to go over are the tools and components that are part of the platform. So we have Artifactory, where you store your binaries, Universal Package Manager, supporting, 27 types of packages, Java and C++, C++ with Conan, and C# with NuGet, and OS packages, Debian, RPMs. Artifactory is not only responsible for hosting your binaries, it's also responsible for hosting your build information, hosting your metadata, quality gate metrics on your artifacts, etc. I'm assuming you are mostly all familiar with Artifactory. I will mention, and show where there are like best practices, but I want to focus more on the other set of the other tools that compose this platform. We have X-Ray for applying security vulnerabilities check and compliance rules. X-Ray is very important in these types of DevOps pipelines, because the main focus here is not to be like an obstacle, a wall in the middle of your pipeline, but to provide you with continuous scanning and help you apply best practices for automation regarding compliance and security. We have distribution, which is a smart tool for distributing your software in a reliable manner to your endpoints. There are a lot of use cases in the automotive industry for using distribution. I will focus a lot on this tool. Distribution can distribute software to regular Artifactories, but most commonly to something called Edge Node. And Edge Node is like a read-only Artifactory, consider a slim Artifactory at production site. It's read-only, which offers you the reliability of, everything is immutable there. Nothing can be deleted, updated, changed without your notice. It's all controlled from a central location from the distribution service. And the only way you can get something to an Edge Node is through distributing something called the release bundle. And I'll go into more details later. In addition to all of these, we have mission control to manage configuration of the platform, to apply access federation, for example, which is also very important, replicating security entities across multiple sites. I'll talk about that as well. And the latest addition to our portfolio is JFrog pipelines. And I will cover a bit of pipelines near the end, but pipelines essentially is a CI/CD tool. And I'm mentioning CD because CD is where most problems or most challenges are. A CI/CD tool centralized, fully declarative, no more like plugin hell and scripting that is very hard to debug and troubleshoot and extend. Integrated natively with all the other tools, and I will again cover that near the end. So we did an eye overview on the platform and the component. Let's start talking about the first challenge, and it's security and compliance. So in this industry, and it's this complex of pipelines and mission criticality of the endpoints and components, we usually have a lot of security practices and compliance rules and gateways that we need to implement. The question is, how can we still retain velocity without sacrificing security and compliance? This relates, of course, to the DevOps metrics about, having shortest possible lead time, and which tools can we use to enforce these types of regulations. There are many tools in the industry, but I want to focus here on X-Ray. And before that, what we need to understand that the majority of the code that is being deployed, and it doesn't mean, just the endpoints, just, updating the cars. It's also like internal processes, doing like testing, machine learning. Essentially, it's not even special to the automotive industry. The majority of the code is not produced in-house, and you can see like it depicted on the right side here, like the iceberg. It's the tip of the iceberg, our code. We leverage about 90 or even more % of code that is open source. It's third-party components, it's dependencies or transitive dependencies. It doesn't usually matter which package type you are using, be it Java, C, NPM, .NET, even operation system itself, lots of packages, RPMs are installed, which are, based on third parties. So what X-Ray is doing, overview on X-Ray, it's a binary scanning tool. It knows how to index your components, your binaries, and find what are the components, subcomponents, dependencies, and transitive dependencies that, compose this binary. This indexing operation happens only once. And then, the scanning operation is essentially, let's match the component graph that X-Ray indexes against the vulnerabilities database and license database that we have. And then, this is the important part. According to policies we define, take some automated actions according to that. Because if we end up at the end just handling reports about all the problems that we have, and someone needs to go manually through the reports, we are not actually implementing good DevSecOps practices. We have a wall in the middle of our CI/CD pipeline, and then we need some manual process to get our binaries over that wall. Instead of that, what we believe should happen is have a continuous scan, have policies enforcing some automated actions as much as possible, and then if need be, use some manual process for approval of something suspicious and go over some edge cases and not, applying that to every single violation or binary that goes through the pipeline. For example, here you can see that a policy that identifies a critical or high severity violation should fail the build, should quarantine the artifact in Artifactory. But let's say that if we encounter a minor violation, let's just do some kind of notification via email, via instant messaging like Slack or Teams, something like that. So, and I will show a demo shortly, but again, efficient scanning is at the base of it. Index only once. Each artifact is being indexed once because component graph doesn't change. So for example, if you have a Docker image and inside of it there are layers, .gz, inside of those there's like an Ubuntu package that has some violations. This component graph is being indexed only once. This is the heavy lifting, and then applying the scanning itself should be very quick and take some automated actions according to that. Scanning tool doesn't matter, you know, how good it is or the features that it provides if the quality of vulnerabilities is not good. That's why, for example, with X-Ray, we have signed a partnership with Risk-Based Security, integrating VulnDB, one of the leading vulnerability databases in the industry. So, and here you can see it depicted like, you know, whenever a vulnerability is introduced to the code, once it's being discovered, a race begins between, you know, hackers trying to leverage that and, you know, have a targeted attack on the end platform, between, you know, the company trying to fix the vulnerability and essentially protect themselves against, you know, hacking and leveraging, exploiting that vulnerability. So VulnDB is very good at, you know, providing information about, you know, these vulnerabilities even before they are publicly announced and scripted. And so X-Ray, based on, you know, vulnerability information for VulnDB, enables you to identify and get notified about this vulnerability, you know, in the early stages, which will enable you to get it fixed before, you know, hopefully hackers can target it and exploit it. So I want now to show you a bit about, you know, how it looks in real life. So let me just switch into my demo environment. So unified. I will log in into the platform now and we'll have a look at X-Ray and how you can leverage that to get your policies. So, and I will go over what is depicted like in the demo environment and the topology when I will go into more details about distribution. What I want to focus now is about the security and compliance. And essentially what you usually do with X-Ray is you define your policies. So policies, there are two types of policies. There are security policies and license policies. So demo security policy. The policy type will be security. And then a policy is composed of a set of rules. And I want to emphasize the important part. So let's give it a name. So a security rule is triggered by either providing a security, you know, a vulnerability threshold, severity threshold, or a CVSS score range. So let's target here a rule targeting high severity vulnerabilities. And then the important part are the automatic actions. So again, this is what I want to emphasize. I will not go over each feature of the tool. You can, you know, download the trial, write yourselves, but the important part here is that we want it to be part of the CI/CD pipeline, of the part of the DevOps, to implement good DevSecOps practices. And one of the practices is automate as much as possible. So what do you have for automation from X-Ray? So when you define a rule, for example here, for high severity vulnerabilities, the automatic actions that we get are the following. First, a violation. So this is actually mandatory. There's no like option to uncheck this generate violation checkbox. This means that X-Ray will generate a violation, a record in X-Ray's internal database, which you can later on interact with. And I'll give you an example. Let's say that you have a component that has a violation. Let's not call it high severity. Let's say it says medium or like minor violation. And then, or even let's say high severity, but then there's no fixed version for that component. It's like a core dependency that, you later on realize that either you are not using the workflow that, triggers this actual violation, or there's no fix, but you must deploy that to production. Things like that can happen. And then what you'll want to do is you will want to ignore this violation. You will want to say, okay, for now, for the current version, current scan, I don't care about this violation. Next time we do a scan, we get an updated component. We want to trigger that again. Or you can say that, no, we are not, actually like invoking that specific function from our code. We can ignore this violation from now onward. So you will have options to ignore violations, to essentially, interact with violations. So that means that, X-Ray will generate a violation which you can interact with later on in a more manual approach. Triggering webhook, this is very important. Essentially this will instruct X-Ray when this rule is being triggered to send a JSON snippet describing, all the vulnerabilities, license information, and the vulnerable component details to some REST endpoint that you define. Essentially, this will allow you to create any type of integration, any type of automation. Now, the important part, that is per trigger approach. Examples. So we have implemented here, for example, sending Slack messages. So what I can define here is that whenever this rule is being triggered on a component, send a Slack message about, the information that caused this to trigger to a Slack channel. You can create an integration that, will create Jira tickets, integrate with other IAM applications, or again, any type of integration that should trigger per whenever this rule is being triggered. So this is important. This will allow you to customize and create automation. Next, some usual suspects, email notifications. So with email notifications, what we have here, you have two options that you can combine. One is notify the deployer of the component, the developer that was responsible for deploying this component, and or the watch recipients. So watches are the glue that binds policies to different resources. And when you define a watch, you can define email recipients there. So you can notify those. And I'll get into why watches are important shortly. Next, probably the most important part in the automated actions is blocking downloads. So essentially here, if I'm checking this checkbox, I'm instructing X-Ray to block downloads or quarantine the suspicious component. We got an high severity vulnerability. I want to quarantine in Artifactory that component. Effectively, you will not be able to download, promote, or distribute is next, but you will not be able to download and use that component from Artifactory. You will simply get a 403 forbidden with a comment that X-Ray has blocked this component according to a policy. Next, block unscanned artifacts. This will lead me into one of the best practices. So if something wasn't scanned by X-ray, we wouldn't want anyone to use that. It makes a lot of sense. However, there's a difference between blocking something that is production ready than blocking something that is like, used for development. So as a best practice in Artifactory, we recommend having multiple repositories, at least per, we call it maturity levels. So have a repository for development, repository for QA, repository for staging, for prod, depends on the phases you have or maturity levels you have in your CI/CD pipeline. Now, if something reaches a prod repository, meaning, we tested it, it's ready for production, we definitely don't want to allow anyone to use it if it wasn't scanned by X-ray. So it means that for production level repositories, I would definitely want to check this block unscanned artifacts. On the other end, for development level repositories, a lot of our customers choose not to check this checkbox because a developer now wants to experiment with a new framework. Usually it requires downloading a lot of new third parties. X-ray, it's not a slow tool. It will scan those quite efficiently, but it will take some time, seconds, minutes, depends on the workload and work queue in X-ray. So until that point of time, we want our developers to get a 403 that, they cannot use those third parties. So most companies decide that, they will allow that for development, but then later on when we promote these binaries to higher maturity levels, we definitely want to, quote, wait until X-ray has finished scanning those components. And that means that I will need to define another policy, one which check the checkbox of block unscanned artifact checked and the other without it, and apply those to different repositories based on maturity levels. This is where watches will be important as they bind the policies to the actual repositories, the actual resources. Now, we have also block release bundle distribution. So this relates to distribution use case. Do we want to allow distributing something to edge nodes, to the, let's call it the runtime locations that when this rule has been triggered? So usually you will check that. You will say that you don't want to distribute something that has like high severity vulnerabilities. And this is important because a new vulnerability may be found after that component has reached the production level repository. And then when we will distribute it later, if there are new vulnerabilities found, distribution will be blocked. So this is important, and it, plays very well with distribution scenarios. And last but not least, fail build. Again, very important from automation point of view. We want to identify problems earliest as possible. We want to fail build to notify, everyone that the build has failed because a compliance check has failed, or there is a security vulnerability. So X-ray essentially here will return like a return flag instructing the build to fail. Depending on the CI/CD tool you are using, if you're using, I don't know, like Jenkins, the Artifactory plugin can fail automatically the build. If you're using something else, let's say like GitLab CI, then you can check this flag and fail the build, when you invoke the X-ray scan. And if you are using JFrog pipelines, again, it's like a flag to turn on to fail the build if a policy with fail build true was triggered. Hope that makes sense. And again, I will not go into all the configurations here, but essentially watches are what will bind for example here, the watch will bind the policies, like we have here, security and license policies to specific repositories and builds. I just want to mention, this is also very important, licensing. So again, we are very careful about, not shipping third-party dependencies and using them according to not to abuse like third-party licenses. So usually we get from the legal team a list of licenses that are whitelisted, or on the other end, list of licenses that are blacklisted, that are banned, and you can pretty much define in X-Ray the policies based on rules that will be triggered either by whitelisting licenses or by blacklisting licenses, and essentially the important part, get the same set of automatic actions, triggering webhooks, email notifications, blocking downloads, failing builds, blocking distribution, according to compliance checks, and not only for security vulnerabilities. And as you see here, we go back to the presentation. So again, the focus of X-Ray, it's not doing source code scanning, it's doing binary scanning, software component analysis. It's aimed at providing continuous scanning integration with DevSecOps best practices. And you can apply some of the capabilities to the entire CI/CD pipeline. And actually, this is also important because we understand that we've seen that, security teams are usually very burdened, very overloaded. The workload on the security team is usually very large, to deal with all the vulnerabilities and compliance issues. What we also provide is IDE plugins, and we currently support plugins for Visual Studio, VS Code, Eclipse, and IntelliJ, essentially allowing the IDE to ship the list of dependencies that the IDE understands and knows about your current project to X-Ray to get the vulnerabilities and license information, in real time. And that means that a developer will just see, oh, I'm using several libraries, they have high severity vulnerabilities. Maybe, maybe it's not the latest version. Maybe I can just bump up the version, and then, immediately he or she will see that, the vulnerability maybe went away or not. And if it went away, they can decide to use a newer version or an older version, so that specific vulnerability will never reach the security team and reduce the load on the security team. This is called shifting left towards the beginning of the DevOps pipeline. And we think this is a very good best practice to integrate with your products. Okay, so let's move on to the next challenge. So the CD part, or the distribution focus here. This is where actually the real challenges usually lie. Because, we need to overcome physics to get the binaries. One use case, or the major use case, is like getting software updates to the car. This is very important, but in addition to that, there are multiple other use cases because topology in, organizations, big enterprises in this industry is usually very complex. We have multiple development sites, multiple test sites, and usually globally distributed, some in the US, some in APAC, some in EMEA. And, getting the binaries to the other side with confidence in a secured fashion over sometimes unreliable networks is a very challenging. So some characteristics here, we have large binaries that we need to ship. Sometimes there's high latency. Networks are not entirely reliable here. Verification and reliability did we get on the other side exactly the same thing that we shipped? Sometimes it's not even a single binary. Sometimes it's a bunch of binaries. And if it's a bunch of binaries, we would like to have a transactional nature. Like, let's say we ship to our test site 20 binaries. We want all of them there, or if something goes wrong, nothing to arrive. Especially, if we're talking real live sites that, cars, update from. And then there are also, last mile issues. How do we actually, if we want to update a car, how do we go about and deal with that? So what I want to show now is our distribution tool, JFrog distribution. Let me swing back to the demo environment. So in this environment, you can see the topology. So we have here, let's say, a main development center in Sunnyvale. There's also another development center in EMEA, another one in APAC, in Bangkok. And we have 2 edge nodes, one in Australia, one in EMEA as well. So what are these edge nodes? Let me just recap that. An edge node is like a slim version of Artifactory. You can consider that a read-only Artifactory with all the enterprise features of high availability, of universal, supporting all the package managers, etc., using checksum-based storage. However, the importance of a read-only Artifactory. What does read-only mean? Because we need to get somehow our updates into this Artifactory. So there are very specific ways in which you can get your binaries to the edge node. Actually, there are 2 ways. One, use distribution, which I will go into detail. The second one is having setting there a lazy caching proxy that can fetch artifacts only from an Artifactory. So in regular Artifactory, you can define a remote repository that will fetch, that will proxy some external repository. So in development site, I want to fetch like basic base Docker image. I can point a remote repository to Docker Hub, and then, once it's being pulled, it will stay in the cache and, Artifactory will serve it locally. But it will serve it after fetching that from an external repository. On an edge node, you can only define a remote repository pointing to an Artifactory. So no external packages of any sort can appear there. Then with distribution, I can distribute binaries in something called the release bundle, and I will go into that. You can distribute a release bundle with a set of artifacts to an edge node. Now, those artifacts cannot be deleted, even by an admin on that edge node. Even an admin on an edge node cannot upload just a bunch of binaries, cannot update. So the only way to actually manage what's on an edge node is through the distribution service. This gives you a lot of confidence about what's in my edge node. It's only stuff that I've distributed into. And if I'm not using those smart proxies, lazy caches, then it's just what I have distributed, and I can be very confident that no one has messed with that, and there are no like hacks around, that will try to manipulate and change, what's in an edge node. Regarding distribution itself, so with distribution, the way to work with is create release bundles. Now, everything I show you here is based on the UI because it's, easier for me to demonstrate on a webinar. Keep in mind that, for all of our tools, all of our features, everything supports automation. You have REST APIs to do every task and operation that I mentioned or show you, as well as we have a CLI tool that, most of these operations can be even more optimized by leveraging our CLI tool. So, what's a release bundle? A release bundle has a name, has a version, like everything, and it has a specification. So let's pick one of these. So I've picked a release bundle called DemoRB, version 1047. And then I can go into the spec, and you can see that the release bundle is based on an Artifactory query. We call that AQL, Artifactory Query Language. It's a very powerful query language that you can use to query about artifacts. An example for a complex one can be, I want to query everything from a specific Docker repository that is larger than 100 megabytes, was uploaded in the last 3 months and wasn't downloaded at all. Okay, for example, to use the result set for retention policy, deleting those artifacts, for example. So Artifactory query language is very flexible, very powerful query language, and you essentially define the contents of a release bundle by creating Artifactory query language queries. So you have the queries will be executed against the Artifactory, and then, you can change those queries, until you are satisfied with what's in that release bundle. In our example, the release bundle will include 7 + 9, 16 binaries, actually 2 Docker images. It can, of course, be from different repositories. So you can have, like, I don't know, some Conan packages together with some RPMs, together with 2 Docker images, and one Helm chart. So you define the contents of your release bundle. And then, the important part, you sign this release bundle. So signing, you see here, is disabled because this release bundle was already signed. What does signing mean? When you install distribution, you create a GPG key and upload it into distribution, the private public key, and then the public key is also uploaded to the edge nodes and Artifactory. When you sign a release bundle, it becomes immutable, meaning the content of the release bundle can no longer be deleted, updated. The release bundle itself cannot be updated any longer. It's an immutable view of the content. That means that you are now confident that whatever you have signed is what's included with the release bundle. Now, what you can do with this release bundle is, of course, distribute it. And you can distribute it to edge nodes. By the way, you can also distribute the release bundle to regular Artifactories. This is a good example would be, I've developed something, I want to distribute it to my test site on APAC, and then, distribute back, I don't know, the test results, which could be, I don't know, like high quality HD videos, or I don't know. So you can distribute to the edge nodes. You can actually, if you use the API, the REST API, you can specify more flexible distribution rules. For example, distribute to all edge nodes. For example, distribute to a specific site. Distribute to all edge nodes, start with canary deployment. So you have flexibility in deciding where this release bundle will be distributed to. And then once you select and you hit distribute, distribution will kick, will start, and then, transfer will begin. The transfer itself is very optimized. It uses an Artifactory component called replicator, which is specifically for distribution, performs smart replication. Of course, checksum based, so whatever's on the target will not be replicated. It's also smart regarding like zip files. If there's already like an older version on the target edge node, it will try to understand the differences and decide whether to shift that just the differences in the zip file and not the entire zip if it's not on the edge node. And it will keep retry, due to possibility of unstable network to the target side. So compared to a feature already, existing in Artifactory called replication, distribution is mainly focused on the retry, the aggressive optimization, and the transactional nature. This is very important. If I'm shipping multiple artifacts, I want all of them to appear at the same time on the edge node. Oh, by the way, if something fails, not to appear at all. Of course, behind the scenes, it's shipping them in parallel, in parts, but the edge node will check if it received everything, and when the transaction completes, everything will just appear in the appropriate repositories. Again, this is leveraging the fact that Artifactory and edge nodes are essentially checksum-based storage. So once a binary is already there, like moving it to a different repository is actually something which is a short transaction in the database. I hope that makes sense. And again, remember with X-Ray, I can block the something from being distributed if, an appropriate rule was triggered. So high severity vulnerability, new vulnerability was found. I try to distribute something that I have in production. If it has an high vulnerability, I do not allow the distribution to happen. I block the distribution itself. Sorry, didn't mean to do that. Okay. Now regarding the last mile. So with distribution, the current situation we see with customers is they have in multiple geolocations, some kind of an edge node that can serve, endpoints that are close to that geolocation. But what about the last mile? What about getting the actual binaries to, let's say, the actual car? So this is a hard problem. Everyone in the industry is working on it, is aware of this problem, is working on some solution. Currently, there is we are not aware of a full-blown solution to continuous updates to the actual car. Before that, maybe we'll talk about if we don't have a full solution for that, what about solution for observability? What versions are deployed to which car? Again, there's no current solution for that, no standard for how to manage observability. What we do see is that most of the customers implement some kind of traceability, which, by the way, is something that is more geared toward the automation of the DevOps pipeline. Traceability means that we are not asking what is installed on which car and, according to that, try to operate. Is, oh, we found a new vulnerability, what components are impacted by it? And because, most of the companies, they have some sort of fleet management solution already implemented, integrating Artifactory, X-Ray distribution, the entire platform with the fleet management solution, it is possible to understand that, oh, I got a new vulnerability or compliance issue on a component. X-Ray can trigger a policy, on production level repositories, triggering a webhook, and the webhook can then integrate with the fleet management and understand with distribution and understand, the vulnerable component, the suspect component, what's the impact on the actual deployment. This is, of course, requires some strict policies in the company about, how you do the distribution, because then you will need to say, like, this is our distribution pipeline. We leverage, let's say, distribution, X-Ray, create the release bundles, and then download, using some fleet management to understand what was downloaded to the actual cars, and then leverage, triggered webhooks to apply this kind of automation. Keep in mind, I've also seen some customers implementing plugins, extensions that can be applied to Artifactory or an edge node to record what was and who downloaded from the edge nodes, what version, and essentially implement some observability or observability capabilities that way. It's also possible, due to the nature on the great flexibility with plugins in Artifactory. Okay, so instead, that's what I've mentioned. Instead of asking which version are installed, when you have an issue, we can understand what is impacted by that issue. Do an impact analysis and not, reporting and manual analysis. Access federation. So another part of the platform that can help us, access federation. So we've talked about shipping the binaries to their targets, either, in-house or outside with full-blown distribution. But shipping the binaries is one issue. Permission management is another. So access federation allows you to replicate or manage security entities on your topology. That means that when I'm having my repositories on my development site, let's say in Sunnyvale on the Artifactory, I have permissions on the required Docker and Conan and RPM repositories. Then I create a release bundle and I distribute that release bundle to all of my edge nodes. What should be the permissions on the edge nodes? Sometimes it doesn't make sense to have the same permissions. Other times, we do want to manage these permissions, the same way we manage them in our development location. Access federation allows you to replicate security entities across, topologies. Now, what do I mean by that? So what I want to do is I want to so we see we have our topology, again, one in Sunnyvale. This is the tabular view, 3 Artifactories, 2 edge nodes, and then I can go to Access Federation. And Access Federation allows me to apply security entity replication topology. This is a very long term, to essentially manage security entities in either a star topology, meaning there's one site, I manage, my security entities in one site and I want them to be replicated to other sites, star topology, or a mesh topology, security is being managed on multiple sites and I want, all sites to be in sync regarding the security entities. By the way, it supports not only a single topology, but you can say between all of my development sites, I want a mesh topology, but then I want a star topology from development to the edge nodes. So if I choose like a star topology, here it is, I'm saying I need to specify my source. Let's say it's the main JFrog platform deployment, main JPD, it's in Sunnyvale, and whatever I change there, I want it to be replicated to the edge nodes. Then I can choose which types of security entities do I want to sync. Usual suspects, users, groups, and hopefully it is not like user-based, but group-based, so I can replicate the groups, and the important part, permissions. So permissions of repositories, I can use include, exclude patterns, also replicate access tokens that automation is using. And once I define that, click finish, then whenever I make a change to the selected entities on the main JPD site, then those changes will be replicated eventually to all the targets, in this case, the edge nodes. So this is also important, and it completes the picture of how do we manage, the binaries and their permissions and security entities across, all these multiple locations. So we've talked about that. I want also to mention, and I will not dive deep here into the last tool in the platform, the JFrog pipelines. However, I do want to mention that this is, again, another take on how to best provide value to your DevOps pipelines. JFrog pipelines is a very modern CI/CD tool. Focus here, again, on the CD part. Going to pipelines. So, quick overview. It is centralized. No more, Jenkins sprawl. Everyone installing their own CI/CD tools everywhere. It's centralized. It's built for a high scale, so you can scale, horizontally. Lots of features regarding the node pools and node agents. Can be static node pools for running the agents, where you define and add your machines, your VMs there, or it can be dynamic node pools provided by cloud providers. The pipelines themselves, or before that even, integrations, secret management, all the integration point, how your CI/CD pipeline talks to Artifactory, to distribution, to your Git repositories. So integration is essentially the secret management, and we support a lot of integration types. The secrets themselves are stored in a Vault service behind the scenes. The pipelines themselves, let's pick a pipeline as an example, are fully declarative, YAML-based. You can have a look at the YAML. There are no plugins that you need to install. Everything that works with the tools in the platform, meaning Artifactory, X-Ray distribution. There's a lot of support out of the box and minimal configuration. Supports running Docker in Docker natively. Everything is containerized behind the scenes. Leverages Artifactory for aggressive caching of layers. We understand that the CI/CD tool is measured in build minutes, so we want to lower this number as much as possible. So essentially defining pipelines to perform, end-to-end deployment is very easy. You can trigger great flexibility, triggering, the build from whichever step you want. It's very easy to build like a pipeline of pipelines, implementing the CD parts with JFrog pipelines. I really encourage you. We will not have the time here to go, into deep dive into all the features here, but I really encourage you to download and experiment with JFrog pipelines. So going back, package types. So what we see in this industry is usually, in addition to like regular Java and Golang and Python development, we see a lot of C++ development due to the nature of embedded systems that, all the cars are using. So I must mention, also Conan. If you are not using, package management for C++, package management is very important. This is, before the platform, before, all the X-ray and distribution and pipelines that we have. We had Artifactory. We started as a, binary repository manager supporting then the beginning just Maven. But we understood that, package management is extremely important. Essentially, you don't want to manage your dependencies manually. And with C++, there's of course, the complications or complexity of, different platforms that you need to build for. Conan supports all of this. If you are not familiar with Conan, I encourage you to go to Conan Center and, have a look at the packages provided there. Artifactory, of course, supports Conan repositories. So it is highly recommended if you are not using it to have a package management for C++ repositories as well. And also, one of the popular frameworks, SDKs for, embedded and IoT devices is Yocto. So there is an integration, so you can build Conan packages with the Yocto SDK. Essentially, again, providing value, understanding the composition of your software, which will enable, better understanding, scanning, distribution, and artifact management, metadata management, applying, I'm sure, in addition to all of what we've discussed, there are usually also a lot of quality gates in the development and the DevOps process. Another best practice that I encourage you is whenever you have a quality gate, like external software doing, I don't know, static code analysis, code quality checks, take the important metrics. Usually there's a lot of metrics being generated. These tools, they have their own UI and own databases, but take the important metrics and add those as metadata to your binaries, to your artifacts in Artifactory. This will allow you later to leverage the power of Artifactory query language, and you also have the single source of truth in Artifactory, which is where your binaries actually are. Remember, that we focus so much on the binaries because reproducible build is something that it's a hard problem in theory. Okay, so even if you have all the inputs the same, sometimes, when you build it, the binary will not be the same. Maybe it's an environment variable that is different. Maybe it's just, different hardware, different processor. So keeping your binaries and having confidence that they are there with all the metadata associated is very important. So at the end, another recap on the platform and what we've talked about. So Artifactory, as we all know, I've talked a lot about X-ray, compliance and vulnerabilities, which are very important for our industry. We talked a lot about distribution smartly and in a transactional manner and secured, reliable, transferring the binaries to their destination, be it like, edge nodes for, the ability to download from a nearby location to the car, or the service center, or even between development centers and testing centers, ship, your components for testing, shipping the test results back. Distribution is being used in a lot of, use cases like this. I've mentioned the JFrog pipelines and mission control for managing access federation. I would like to thank you now, and if you have any questions, please post them now on the Q&A channel, and I'll be happy to answer.